Okay, good evening, student. My warm welcome to you. And as our session continues, students, we have to work hard and our commitment for year 2021 not to waste any moment of time. Clear?
Yes, sir.
Our preparation should be strong, our determination should be strong so that we can score full marks in chemistry students. And every student can get good marks. There is no difficulty in that.
Hmm.
It depends on how much hard work we put students. Probably you are aware, students, my video lectures which are coming, I have to work very hard for you people because it will take 3 to 4 hours to prepare and then give the talks and lectures.
Yes, sir.
And the type of technology I'm using, it will cost me money for board, for everything. So these lectures are almost free lectures from our side for all the students. We're not earning anything out of this. It's not possible. But since the students are in need of it, therefore we are trying our best to help you, all the students. Therefore, I always tell the students, please forward our video lectures to more and more students. This provides us motivation to work so much for students. If I make a lesson, it will take 3 to 4 hours, then I will teach you. See, this type of interaction is going on.
Yes,
And
sir.
therefore, we want um, uh, that you should subscribe and send it our video lectures to your friends and they can watch free video lectures for preparation in the coming exams considering that it's a pandemic and children are under great stress students and a lot of
Hmm.
children will find difficulty in writing and answering question in exam because the
Yes, sir.
studies are not very effective.
Hmm.
How there is no interaction between students and school teachers and other interactions, so they are not able to understand everything. And our objective, my objective of teaching chemistry is that it is a science students, we should understand it before we cram it.
Yes, sir.
I mean, cramming has no business here.
Hmm.
Understanding is important, that each and every word, each and every line written in the book be decoded and understood by the students.
Hmm.
NCERT books are very
Yes, sir.
good, but then how to understand each and everything, it will need a proper coaching student and you need guidance for all this.
Yes, sir.
And that is why a lot of students are now facing some problem.
Hmm.
And as the examination will approach, the pressure will build high.
Yes, sir.
As the paper will come, students say, oh, we are not done anything. And they will start excuses and complaints. So this we don't want.
Hmm.
We want that our preparation should be strong and good.
Hmm. Yes, sir.
That's all. So that we can face any type of situation. Student uncertainty continues and we do not know
Hmm.
what will happen. But our preparation should be strong. So students, we are going to give a revision of the solution chapter and certain few questions are going to be solved by a student in this
Hmm.
topic. The topic is solutions student and I am talking of the revision
Yes, sir.
lecture student and certain question students which could be important for us. When you know first what is the solution student, what is the solution, 30 seconds for talking and answering, interact with me, it is good. What is
Hmm.
do you mean by solution student? It is a solution is what type of mixture? What type of mixture is solution student? Small questions will be there, objective type in your paper student, 4 choices will be
Yes,
there.
sir.
So what type of solutions, what is a solution student? It is a homogeneous,
Hmm.
certain important points to be noted student. So solution you
Yes,
define
sir.
as homogeneous student mixtures of two or more components,
Yes, sir.
and our study is mainly for binary solution, means there are two components which we are studying students.
Yes, sir.
Tell me what are those two components which we are studying? One is called solvent, other
And
is
solute.
called
Solute.
solute. ठीक है?
Yes, sir.
Third thing we studied in solution chapter, types of solution, students.
Mm-hmm.
Based on the solvent, we classified the solutions. Can you tell me what are the various types of solution, student? What do you define? Fast, gaseous
Mm-hmm.
solutions.
Yes, sir.
Then what we define, students? What are the other liquid solutions? If I miss something, you will remind me, students.
Okay.
Revision lecture means your participation is very important. Solid solution, students. What do you mean by gaseous solution? The solvent will be gas.
Mm-hmm. Yes, sir.
When the solvent is gas, student, that is a gaseous solution. Gaseous
Mm-hmm.
solution. So if solvent is gas, you can put what? You can put solid in gas, student.
Mm.
You can put liquid in gas, and student, you can put gas in gas.
Yes, sir.
Now, can you give examples of this, student? What is the example of solid in gas?
Hmm.
Fast,
I'm
students.
giving, sir.
Solid in gas, students.
Solid in gas. Sir. Sir. Foam.
Huh?
Hello.
Yes.
Yes, sir. Sir. I don't remember.
You now the question is why I said that you said you have revised the topic.
Mm.
Why do we ask question? This is an exercise, student. We keep on revising, recapping, and this is important that we will forget. We should not forget, student. You have seen so many example. If I have hydrogen gas, student, over palladium, what happens? So palladium is
Sir.
a
Wait. Sir. Wait. I think I remember, sir. Sir. Naphthalene vapors.
camphor in nitrogen.
Yes, sir. Camphor base.
Camphor is a solid in nitrogen
Hmm.
gas, student. What is an example of liquid in a gas, student? Liquid in a gas.
Mm-hmm.
If you have liquid in a gas, student,
So liquid and gas.
yes,
Sir. Uh, Sir. Water vapor.
how will you say that? What is that? You have seen air in air. What is present?
Sir. Cold mix.
If you put air, gas, which gas is present in air, student? Gas is in air. What is that, student? You are aware of the you are aware of the in the air what is there, student? What gas is there? Air is a gas, and what liquid is there in the air? Water.
Mm.
Water, liquid in air. What is that? Basically clouds, all this.
Yes, sir.
If you have gas in gas, you already know what is gas in gas, student.
Mm.
Mixture of what is air? Air is a mixture of gas in gas. You are having oxygen gas in nitrogen gas, student.
Mm-hmm.
Nitrogen is how much percent in the air? This is
Sir, 78.
and this is about 18. So certain type of solutions can be formed. Liquid solutions are those in which the solvent will be liquid.
Mm.
So solvent is liquid. If you have solid, you put in liquid. What example is that, student? You dissolve sugar in water or salt in water. All these are examples of this.
Mm.
Sugar is a solid. You put in water, student, or you can put salt in water, students.
Yes, sir.
And if you have liquid in liquid, what type of examples are these? You put alcohol in water.
Hmm.
Ethanol is a liquid and water. These are the certain examples we should be aware of, student. Then
Yes,
you
sir.
have solid in a liquid, student. Solid we have already done. Then you have gas in a liquid. You already know oxygen is dissolved in water. Water liquid. Solid solutions are those in which the solvent will be solid. Clear?
Okay, sir.
And you can put gas in solid. You can put gas in solid.
Hmm.
You already said you can put hydrogen gas in palladium. Or you can put, student, liquid in solid. If you have sodium and mercury amalgam,
Hmm.
amalgam student. This has been asked somewhere in the paper, amalgam. And solid, you know, what are the solid alloys? You know, copper is mixed with
Yes, sir.
gold.
Sir, steel, sir, steel, iron with carbon.
Solid. So these are some of the example, students, we are aware of it. Okay. Then students, we expressed the concentrations of this concentration, expressions of concentrations of solution, students. The most important one I am talking about, what is the mole fraction, student? Which we use a lot. If there are two components N and B, they are the moles of A and moles of B. Then what is the mole fraction of A? Na by
N total.
B, and what is the mole fraction?
Na plus B, Na plus NB, yes, sir.
Okay, NB by
Na plus NB.
NB, and the total is always 1. And
Yes,
what is
sir.
NaWa by Ma? And what is NB, student? WB by MB. Okay? Does it depend on temperature? Yes or no? Fast. Question is put up like that, students. Is it dependent on the temperature? Mole fraction?
Yes, sir. No, sir. No.
No.
No, sir.
Because moles will not change if I change the temperature. Does not, important student, certain questions in between they will be there. Does not depends on temperature, student. This is an important point. Then you talk the molarity, student. What is that? Moles of the solute per liter of solution.
Yes, sir.
Per liter of the solution. Moles of the solute is N2, student, and V liter of the solution, which is W2 by M2, student, and this volume in liter of the solution. Okay. What is the third important one? We define, student, molality. Moles of solute per. Tell me, what is the coming in the denominator?
In molality, sir,
Yes.
upon kg, weight of solvent.
Kg of the solvent. Moles per kg of solvent. Moles per kg. What is the mole, student, of the solute? N2 by M2. And this is the mass of solvent in kg, students. Now the question is, out of the molarity and molality, which depends on the temperature, student, which depends on the temperature? Molarity depends on temperature, yes or no?
Yes, sir.
Molarity depends.
No, sir. No, sir. No, sir. No, sir. No.
No, sir. Why?
No.
Volume will depend on the temperature or not? What do you say?
It will depend, sir.
Volume will change with temperature. So
It will
that
change, sir.
depends on temperature. Important point, question has been asked. Molality. What molality? Will it depend on temperature? Yes or no? Fast.
No, sir.
Why? No.
Because it's the weight of solvent and it won't change.
Mass does not depend. Mass does
Yes, sir.
not depend on temperature. Anything which is mass, student, it does not depend on temperature. Mass doesn't change with temperature. You will keep on noting everything. These are important things, student. Okay. 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 Let us see more information, students. Question we will try later on. Okay. Then we told you about the solubility, students, in this topic. What is the solubility, students? The maximum amount that can be dissolved in a given amount of solvent.
Yes, sir.
At a given temperature and pressure, students. And we have said the solubility of solid in liquid, for example. Okay. Does it depend on temperature?
Let me. Sir, I think so. Yes, sir. Yes, sir. It will increase the temperature.
It depends on the temperature.
Yes,
because
sir.
there is an equilibrium. You have a solid. You are putting in solvent, student, and if heat is absorbed, you have a solution. There is an equilibrium, student. Whenever such an equilibrium is there, what will happen? So, student, in the dissolution, if delta H, what I am saying, delta solution H is greater than 0 positive, then what will happen if I increase the temperature? If I increase the temperature, the solubility will increase or decrease. 30 seconds.
Sir, it will increase.
Increase. Why? Because delta H
Sir, yes,
positive
sir.
is endothermic. So if I put more heat, it will go forward. This is the basis of leach at layer principle. Okay?
Yes, sir.
This is what type of reaction is this? Endothermic, student. Endothermic process. And student, if you have solid plus solvent, solution plus heat, delta solution H is negative. What is this? Exothermic. So what will happen if I increase the temperature, student? Solubility increase or decrease?
Increase, sir, increase.
Huh?
Sir, increase.
Decrease.
No, sir. Sir, I meant with increase in temperature will increase, no?
Huh?
Sir, higher temperature will increase.
Why it increases? What is the leach happens by heat is on this side, so it will go back.
Oh, sorry, sir. I made opposite. Yes, sir.
Why I am doing all this? Because you should be careful. Certain questions are been put in the paper, students. You should be careful. The science student, increase in temperature decreases the solubility.
Yes, sir.
For reactions which are exothermic, or reactions which are. Is there any effect of pressure on solubility of solid in liquid?
No, sir.
No.
Oh, wait. Yes, sir.
No. Insignificant. There is not.
Yes, sir.
The solids and liquids are highly incompressible. What is the answer? Solid liquids incompressible. Therefore, insignificant. Okay. You have noted down everything. Keep on noting, students.
Yes, sir.
Because there could be question on that. Revision means we should know what we are doing. Okay, student. Now the important thing is coming. What is that? What is coming? Students.
Hmm.
Just a minute. Okay. The important question is going to be on solubility of gas in student liquid.
Yes, sir.
Which law is there, student, which governs the solubility of gas in liquid? Question: what is Henry's law, student? Important question will come. What is Henry's law? Fast. This is an important question, favorite question for the exam. What is Henry's law, student? The solubility of a gas in liquid is directly proportional to pressure of the gas. More the pressure, more solubility is there for the gas, student. And other words, mole fraction of gas in a solution, mole fraction of gas in a solution is proportional to the partial pressure of the gas over the solution.
Okay, sir.
How you write? P is equal to KH into X, student. So what is P here, student? What is P? Partial pressure of the gas. Partial pressure of the gas, student. ठीक है?
Yes, sir.
Partial pressure of the gas in vapor phase is proportional to, student, X, the mole fraction of the gas, student. Mole fraction of the gas in the solution. More the mole fraction of the gas in solution, more will be the partial pressure.
Yes, sir.
And KH is the Henry's law constant. What is KH? Henry's law constant. What will be the units of KH, student? Question. What will be the units of KH?
Sir, there'll be mole.
How do you calculate the unit, student? Again, you are doing a difficult. You are know what to calculate the unit, student. What are the units of mole fraction?
Sir, it will be, I think. Wait,
X is
so
only a
mole fraction has
number.
no units. Yes, sir.
Then what will be the units of KH? The units will be of the unit of pressure. What are the?
Yes, sir. Fine.
This has no units. So what are the units of pressure? You know, pressure. What do you use? Bar.
Yes, bar.
Atmosphere. Whatever you use, student. The same unit will be there for KH. Therefore, student, what you are finding? The KH is inversely proportional to the mole fraction of the gas. Higher the mole fraction of the gas in solution, lower is the KH. Lower is the KH. And KH depends on nature of the gas.
Yes, sir.
For different gases, the KH is different. It is not that all gases are the same. It is a function of nature of the gas, student. Now more the solubility of gas, student, lower will be the KH. If KH is more, the solubility is less.
Okay.
Solubility is less, student. And with increase in temperature, KH increases and therefore solubility of the gas in liquid decreases. Okay.
Yes, sir.
These are the points to be noted, student. There could be question put up on that. The important question is there. They will ask you about Henry's law. So the solubility of gas is more in cold water or in warm water, student?
Sir,
What is the effect of temperature, student? Important question. On
sir,
solubility.
it'll be yes, sir. Sir, it'll be more in cold water.
So with increase in temperature, solubility decreases, student.
Yes, sir.
With increase in temperature, student, solubility of gas decreases.
Jesus.
Important question has been asked so many times, student, in objective type also. The aquatic life is more comfortable in cold water or hot water?
Yeah. What, sir?
More comfortable in
The cold, obviously cold.
cold water. Because there is more oxygen than
Yes, sir.
oxygen gas is dissolved in water, student. So there will be more of oxygen. So they will be more comfortable. Give me two applications of Henry's law. Question has been asked many times, student. What are the two applications of Henry's law? Fast.
Giving, sir. Sir, one in making cold drinks.
Huh?
Sir, in making cold drinks.
What is the application? Tell me. Cold drinks we are drink. What you have to write in the paper, student?
And sir, second.
What is I'm saying this is not an answer. Cold drinks. What do you mean by cold drinks? What it has?
Oh,
You
yes,
tell
sir.
me. What is in the cold drink?
Sir, gas.
Which gas you have to write? You
Carbon
write
dioxide.
only
Carbon
cold
dioxide,
drinks.
sir.
Nothing. 0 marks for that.
Okay, yes, sir. Sir, carbonated soft drinks.
Carbon dioxide. What do we do to increase the solubility? We are talking of solubility of gas in aerated drinks. Which to increase the solubility of student
Of CO2, yes, sir. CO2.
solubility of
CO2.
CO2 gas in aerated drinks. This is not complete. What we do?
Yes, sir.
What do we do? They are sealed at
A high pressure.
high pressure. So did you write that answer? No. Then what mark you will get nothing. So be careful. So you have to see what you have to write in the answer. You can't write anything. Answer should be specific, short, and to the point. What is the other application?
Sir, it helps scuba divers.
What are they again? Scuba. What they do? What is the application?
So telling.
Scuba diver. Anyone is scuba diver. Then what is the application in the scuba divers?
Sir, the pressure increases with depth.
This is not the answer. This is not the answer.
No, some telling.
You
So,
see
sir,
that?
as we go down, the pressure increases. So this causes more nitrogen to be absorbed out of the body.
Then what will happen?
But
What is the
coming
application of? Where is the Henry's law in this? Where is the application of Henry's law? What application of Henry's law we are talking about? This answer is not acceptable.
Okay, sir, I'll explain. 2 minutes. Let me
You just
explain. No, sir, I'm trying to phrase my.
Okay. You know that down the sea, what happens?
Sir, more pressure.
Pressure increases. Then what happens, student? If the pressure increases underwater, the solubility of atmospheric gases increases.
Increases.
And in the atmospheric gases, what you have, student? Nitrogen gas is also there. So
Yes,
what will
sir.
happen, students? The atmospheric more of these gases will enter the blood. If you are carrying a tank cylinder, student, when you go deep down the sea, there is a tank
Mm-hmm.
of the gas which you are taking with you. And when you will come to the surface, pressure gradually decreases and released dissolved gases will lead to formation of bubbles of
Mm-hmm.
nitrogen in the blood, student.
Yes, sir.
The nitrogen gas bubbles will be there in your blood when you come out.
Mm-hmm.
And you know what disease is that called bends. So what will they do then? The tanks used by scuba are filled with air, diluted with air. The tanks which are used, student, the air is diluted with 11.7% helium gas, student. ठीक है?
Yes, sir.
So
Mm-hmm.
the toxic effects of high concentration of nitrogen. Toxic effects of high concentrations of nitrogen. Nitrogen gas is toxic.
Yes, sir.
You see that it is not that you have a understanding what you will write in the paper will make all the different students. Then we discussed with you, student, important law. What was the important law, students, which we talked in this, student? What was the
Henry's
important
law.
law? Vapor pressures, Raoult's law.
Also, yes, sir. Also.
Raoult's law. Student, what is Raoult's law? For solution of volatile liquids.
Yes, sir. Sir.
For solution of volatile liquids, what is the statement of the Raoult's law? Important question.
Sir. Yes, sir. It states that in a solution, the vapor pressure of a component at a temperature is equal to the mole fraction of the component
Equal to
into
what?
the.
Proportional to the
Yes, sir.
partial pressure of each component.
Hmm.
Partial pressure of each component, student. ठीक है?
Mm-hmm.
In the solution is directly proportional to what? Mole fraction.
Yes, sir.
What is the mathematical, if you remember? If I say that P1 is proportional to X1, P2 is proportional
Yes, sir.
to X2, if there are two liquids, both of the liquids form, student, are volatile.
Mm-hmm.
You have liquid 1, you have liquid 2, they are volatile.
Yes, sir.
They will form, student, vapors. So they will have partial
Mm-hmm.
pressures. And then what was it? P1 is equal to P01 chi1 and P2 is equal to P02 chi2.
Mm-hmm.
Yeah. So what will be
Yes,
the
sir.
total pressure then? P1 plus P2 is equal to P10 chi1 plus P02 chi2. What is
Mm-hmm.
P01, student? What is P10? The vapor pressure of the pure.
Yes, sir.
This is the vapor pressure of pure 1 and P02 vapor pressure of pure 2.
Mm-hmm.
We have derived an important formula also, student. They will ask in the derivation what was that, student? P10 You can write it because chi1 plus chi2 is equal to 1 student, and what will be chi1 1 minus chi2, put the values here, what will you get? P1 0, and then you can write P02 minus student P10 into chi2. ठीक है?
Yes, sir.
What type of graph you was getting, student? Vapor pressure versus mole fraction. You have seen in the books. Vapor pressure
Mhm.
versus mole fraction graph you have seen. Important question is put up from the Raoult's law.
Yes, sir.
Raoult's law. Okay, revision of the Raoult's law, student. What we said, student? What are ideal solutions? What are ideal solutions, student? What are ideal solutions? You have 30 seconds. Ideal solutions are those which obey the Raoult's law over the
Yes, sir.
entire range of concentration. Obey Raoult's law over entire
Yes, sir. Sir, overall, over the whole,
range of concentrations.
yes, over the area.
ठीक है? What
Yes,
are
sir.
the important properties of Raoult's law? What are the important properties of ideal solution, student? 30 seconds for that question.
Mm, 2 minutes, sir.
Keep on working, student. Must work on each and every question, that is important. Enthalpy. What is enthalpy of
Yes, sir.
mixing?
Yes, sir. Sir, the enthalpy is 0.
Of mixing.
Yes, sir.
Array,
And
what?
and the
Mixing
volume of
zero.
mixing is also 0.
And
The volume of mixing is also 0.
volume of mixing zero.
Yes, sir.
Delta mix volume zero. That will mean, student, the interactions between the two components which we are mixing, they are almost equal, because there are two
Mhm.
components, A and B, students. There are A interactions, pure, and there are B interactions, students.
Yes, sir.
When AB interactions are almost student same, ठीक है? When
Mhm.
AB interactions are same, student, what will happen? Are almost equal to
Yes, sir.
A and B, then they will form an ideal solution, student. Can you give
Mhm.
me an
Okay, sir.
example of ideal solution?
Sir, they don't exist.
Give me example of the ideal solution. What, that is not an example.
Exam. Uh, Sir, benzene and ethyl bromide. Benzene and toluene.
Huh?
Sir, benzene and toluene.
What, well learned from ideal solution? Well, I'm talking of two volatile liquid, students. Benzene and, if you have normal hexane plus normal
Mm.
heptane, they have similar type of forces. Interaction between intermolecular attractive forces are same.
Yes, sir.
Intermolecular attractive forces are same, students. Then we say that they'll form an ideal solution. If you take
Okay,
benzene
sir.
and toluene, this is our benzene, student, and this is my toluene. The interactions are almost equal. So see that this is the point to be noted. Important question is coming on deviation, student. What type of
Yes, sir.
deviations are there from non-ideal solution, students? Non-ideal solutions. Two
Hmm.
types of deviations, students. What is that? Positive deviation from Raoult's law. What will happen? If the interaction forces are weaker, when solutions are mixed, the result will be what, student? The vapor pressure will be more, and this
Yes,
will
sir.
exhibit the vapor pressure plots will be higher than predicted by the Raoult's law. ठीक है?
Hmm.
तो positive deviation means student AB interactions are
Yes, sir.
weaker than AA, than AA and BB interactions. Clear?
Yes, sir.
We have to understand everything, student. Then only we will be able to answer.
Okay.
Positive deviations will be there, student, and that means AB interactions are weaker than this. Student, give me example of positive deviation. This question has been put up many times in the exam. You have 30 seconds. Give me at least one or two examples, student,
Off, sir.
of positive deviation from Raoult's law.
Hmm. Um. Sir, I'm remembering. Um.
Mixture of
So 2 minutes. 2 minutes. 2 minutes. 2 minutes. Sir, acetone and carbon disulfide,
if I mix ethanol
acetone
and
and benzene.
acetone. Second, what you are saying?
So, sir, benzene and acetone.
No, you just can't. What interactions are there between them? You have to be careful, student.
Hmm.
Carbon disulfide and acetone. What happens in alcohol? Array, you know, it is easy. What in alcohol? What is happening, student? What happens in alcohol molecules? Negative, positive,
Hmm.
negative, positive. What is happening here? There is a intermolecular hydrogen bonding.
Yes, sir.
And when you will add acetone in it, what will happen? First case, first example. Add acetone, what will happen, student? Then certain amount of hydrogen bonding will be decreased because alcohol, this alcohol, student, this interaction will become weaker,
Hmm.
and therefore there will be a positive deviation.
Yes, sir.
In the second case, student, if you have acetone, CH3, you know that this is negative, this is positive. So there are
Hmm.
dipole-dipole interactions
Yes, sir.
between acetone molecules. And when you add carbon disulfide, they will become weak. So there will be
Hmm.
positive deviation.
Okay, sir.
They have to be answered in terms of the interactions. Clear?
Yes, sir. Yes, sir.
Okay. These are the questions have been put up in many cases. Student, we are giving those examples. Student, the second one is a negative deviation, student.
Hmm.
Negative deviation from Raoult's law.
Hmm.
Negative deviation. What will happen when AB interactions are stronger, student? Stronger
Yes, sir.
than AA or BB, the vapor pressure will decrease as predicted by the Raoult's law. Example, give me example of that, student. Example of this.
So negative deviation.
You have 30 seconds to answer.
Sir, benzene and chloroform.
Benzene and chloroform, what will they do? How, on what
Water
basis, what type of interaction? You have to tell the interaction, student. You can't blindly write anything.
yes. So water and its
What will happen here when you mix the two? If I mix the two, there will be stronger
mm-hmm.
intermolecular hydrogen bonding.
Yes, sir.
And then what will happen? The molecules forces of interaction are stronger. The vapor pressure will be less than as predicted by the Raoult's law. In this case, you already know what happens, student. CH, Cl, Cl, Cl. This is highly electronegative. This carbon is positive, students, and then this will also become positive. This will attract the electron towards itself. So what will be the
Mm-hmm.
result of that, student? If you have C double bond O, CH3 students,
Yes, sir.
these are highly negative. So this is negative, student, this is positive. There is going to be a strong intermolecular hydrogen bonding here. So they will show negative deviation.
Okay, sir.
Student, negative deviation. Got it?
Yes, sir.
These are the questions that have been asked, student, which have been asked repeatedly, students. Then they will ask you what are azeotropes, student. You have 1 minute to answer the question, students. What are azeotropes, student? Binary mixtures. Binary mixture, student, which have the same composition.
Mm-hmm.
Same composition in a liquid and vapor phase. What will happen? They boil at constant temperature.
Yes, sir.
And they boil at constant temperature, student. And then it will not be possible to separate them by fractional distillation. Okay? So
Yes, sir.
cannot be separated by fractional distillation, students.
Yes, sir.
They cannot be separated by fractional distillation. They are called azeotropes. You have a minimum boiling azeotrope, student. Okay?
Mm-hmm.
Which show
Yes, sir.
large positive deviation. Large positive deviation from Raoult's law. They will show,
Mm-hmm.
they will exhibit minimum boiling azeotrope.
Yes, sir.
Example 30 seconds for that. Ethanol water mixture, student. What is the
Yes, sir. Yes, sir.
composition? When a composition will arrive, which will be 95% by volume of ethanol,
Okay.
then they will form an azeotrope, students, azeotrope. And they will become constant boiling liquids.
Mm-hmm.
And then there is student further maximum boiling azeotrope. The question have been asked in the paper, student, you should remember.
Okay, sir.
Those solutions which show large deviation, which one? Negative, from Raoult's law.
Yes, sir.
From Raoult's law. They will exhibit, student, maximum boiling azeotrope student. For example, 68% student HNO3, 32% water by mass student. ठीक है? The boiling point of this is
Sir, your
393.
voice is breaking.
Boiling point is 393.5 Kelvin. Any difficulty? Tell me, is there any difficulty?
No, sir. No, sir.
Okay. So students,
No, sir. No, sir.
here we have given you a large amount of revision from the chapter of solutions,
Hmm.
where we have discussed questions are likely to be there. Certain things I discussed
Hmm.
become part of the question, students, part of the questions
Okay, sir.
in the coming exams. In the coming exams, students. So this is the first part of that. The second part we will do with certain questions. We will take a class, students. Tomorrow
Hmm.
is Friday. We will take on
Okay,
Saturday
sir.
and Sunday. Saturday and Sunday. ठीक है?
Hmm.
Because the paper is on 11th now.
Yes, sir. Yes, sir. On Monday.
Okay.
Okay, sir.
So
Thank you, sir.
I will see if it possible tomorrow. Then I will inform you at it,
Okay, sir.
so that we can revise and do more and more questions. Meanwhile, you keep revising and make sure what you are writing should be correct. Student, you can't answer anything. There will be objective type question. One of the answer will be correct. So we have to be careful. ठीक है? So this is the first part of the revision of the solutions. You solve questions on this meanwhile, and then we will proceed further in the next class. These are important questions which have been put before you. They will be asked in objective type forms in the paper. ठीक है? They will give four choices or what is right, or assertion, and this sample paper was sent by me to you already for 12th chemistry, but depends how much course is coming in the paper. Because for the board we have to do complete course, students. There is no excuse. Syllabus has already been decided. Yes, full course. So all the topics to be revised with question answers in the coming time, as the paper of CBSE is coming on 4th of May. ठीक है? Okay then, good night.